Welcome students. In this class we will be studying about those equations which are reducible to exact differential equations. So this is the key word. So what exactly does it mean? It means if we are given a differential equation and if we are able to represent this as mdx plus ndy is equal to 0, then we would attempt to obtain this condition, right? Dou m over dou y. If this condition holds good, then we would conclude the given differential equation to be an exact differential equation. Now, the question arises, what would happen if this condition fails? Obviously, though the given equation is a differential equation, it isn't an exact differential equation. So now there is a issue. Though the equation is a differential equation, it isn't an exact differential equation. So what should we do to make that given differential equation to an exact differential equation? So that is all this study is connected with. Now foremost, what you have to do is you will have to make the following check. The check is see if this fails. That's exactly what we are going to do. So let me just start to check if dou m over dou y is equal to dou n over dou x. Right? So clearly from here I can see m is x squared y negative 2 times xy squared, and my n is, this is actually negative, right? So negative of x cubed negative 3 times x squared y. So this is my n. Now we will find out what is dou m over dou y, differentiating this entire thing partially. So this is going to give me x squared, this is going to give me 4 times x times y, and coming to n, it's going to be dou n over dou x. So I'm going to differentiate this. This is going to give me 3 times x squared, this is going to give me negative positive 6xy. So if I were to box this, so clearly what do I see? Clearly, let me give this number as 2 and 3. From 2 and 3, we observe that dou m over dou y is not equal to dou n over dou x. So this would mean if I were to take this equation to be as 1 is not an exact differential equation, right? So the question comes is, how are we going to connect, or in other words, how are we going to convert it into an exact differential equation? Now number 2, so first is we have undergone this stage. Number 2 is we will have to check if 1 is a homogeneous equation. That means the degrees should agree. So we have given this x squared y negative 2 times xy squared times dx, and then this is followed by x cubed negative 3 times x squared y times dy is equal to 0. Just check the powers. The total degree here is 2 positive ones, 3. It's 3 here. X is 1, y is 2, so 3 here. It's 3 and it's 3. So this is 1 is clearly homogeneous, right? So once we complete this check, we will have to go and find the integrating factor. Now what is the integrating factor? It's nothing but 1 over m times x positive n times y. Now from this we know the value of m, we know the value of n, so I'm going to substitute it here. So let me find out what is mx positive ny equal to. So as I mentioned to you, I know my m, which is x squared y negative 2 times xy squared. This has to be multiplied with x. Positive my n is negative of x cubed negative 3 times x squared y. This has to be multiplied with y. So this would give me x into x squared is going to be x cubed y negative 2 times x squared y squared. You have a negative times positive is a negative, so it's going to be x cubed y. Negative times negative is positive, so 3 times x squared y squared. So clearly x cubed y cancel, so you have negative x squared y squared, that can be added here. So we would now have x squared y squared. What is this? This is mx positive ny. Now we are expected to find the integrating factor, so therefore the integrating factor is nothing but 1 over mx positive ny, which is nothing but 1 over x squared y squared. So we have got this. Now what should we do? We have to take this, and let me just take this as say 4. We have to take this and multiply the original given equation by this 4. That is exactly what we have to do. So that is what we are going to perform now. Okay, so this is step 4. Okay, step 4, we will multiply equation 1 with equation 4. Okay, so in other words, I would say we will multiply 1 with 4. That's what we have to do. So this is going to give me x squared y negative 2 times x y squared times dx. The term is x squared y squared followed by negative sign, and x cubed negative 3 times x squared y times dy divided by x squared y squared is equal to 0. So okay, now let me simplify this. I have to rewrite that. So that is going to be x squared y. I can rewrite it like this: x squared y divided by x squared, this is x squared y squared, negative 2 times x y squared divided by x squared y squared, this is with dx, and then that's followed by negative of x cubed divided by x squared y squared, negative 3 times x squared y divided by x squared y squared. So this is going to be dy is equal to 0. So now what we would do is we will cancel the terms x squared y x squared and x squared, and a y and a y, and x and a x and a y squared and a y squared, x squared and x squared gets cancelled. This is x squared, and the y gets cancelled. So this is going to be 1 over y negative 2 over x times dx, negative, this is going to be x over y squared, negative 3 over y times dy is equal to 0. So this is what we have got. Now I can rewrite this in this form, rewriting in mdx plus ndy is equal to 0 form. So it's going to be 1 over y negative 2 over x times dx, positive negative of x over y squared negative 3 over y times dy, in fact is equal to 0. So I just want to have a plus there. In fact, I should have placed the dy outside of the parenthesis, so that way we would have this form mdx plus ndy is equal to 0, but it's okay, never mind. So from here I can state that my m is equal to 1 over y negative 2 over x, and my n is negative of x over y squared negative 3 over y. So now the question comes, we will have to find dou m over dou y. So this is going to give me negative 1 over y squared. This cancels off. Now dou n over dou x, this is going to give me negative 1 over y squared. This cancels off, right? So this implies dou m over dou y is equal to dou n over dou x, which means the equation, okay, the equation is now in exact differential equation form. Okay, so that is the understanding we have achieved here, all because of this condition being true. So having obtained this, now it's time for us to solve. So I'm going to say consider integral m dx, which is equal to integral, my m is 1 over y negative 2 over x times dx. So this can be rewritten as 1 over y is a constant, so it's going to be integral dx negative 2 times integral dx over x. Now this can be rewritten as 1 over y times x negative 2 times ln x. So this is what I've got. Now I can write this as integral m dx being equal to this, so I will box this up, and after this it's time for us to consider, okay, consider integral n negative dou over dou y of integral m dx times dy. Now this is equal to integral, my n is this quantity, right? So I need to substitute that, so it's going to be negative. In fact, if I were to take the negative sign out, I can start with the positive sign. So this is going to be 3 over y negative x over y squared, okay, followed by negative dou over dou y of this quantity. What is that? X over y minus 2 times ln x. So this entire thing has to be has to carry the differential operator dy. So probably I will just change this to a parenthesis like this, and then I will have the integral sign like this. Okay, so now if you have to differentiate, so this is equal to integral, so I'm retaining as it is 3 over y negative x over y squared. If I were to differentiate this partially, dou over dou y of x over y, so this is going to give me negative x over y squared, right? And differential of 2 times ln x, this is partially differentiation with reference to y, so this will get vanished, so all it remains is this times dy, and I need to place the parenthesis there. So if I were to rewrite this, this is going to be integral 3 over y negative x over y squared positive x over y squared times dy. Now clearly negative x over y squared positive x over y squared can be cancelled, giving me 3 times integral dy over y, which is equal to 3 times ln y. So this is what I've got for this. Now we will have to give the complete solution, right? So that's exactly what we're going to do. So hence the complete solution is going to be integral m dx positive integral of n negative dou over dou y of integral m dx times dy, right, is equal to constant c. Now this one, integral m dx, is this quantity, so x over y negative 2 times ln x followed by a positive sign and 3 times ln y is equal to constant c. So this is our final solution. Of course, you can take this 2 onto the head of x and 3 onto the head of y based on your requirement. So that completes this beautiful question, students. So we will move on to the next one. Students, we are continuing our study on reducible to exact differential equation, and this particular illustration is of second form or second variation. So what exactly does this particular variation mean? So I'm going to show you what exactly it means with the following understanding. Now we are given this, given that m dx plus n dy is equal to 0, and if we can represent this as f of xy times y dx positive f of course this one is some function f1, this is some function f2 of x dy is equal to 0, then the integrating factor is going to be 1 over mx negative ny. Now it is imperative to understand that the condition has already failed here. Now provided, of course, let me write that down, provided of course dou m over dou I is not equal to dou n over dou x. Because if this condition is valid, then there is no reason for us to apply this format. Now when I say f of xy, it means function involving x and y together. So in other words, x and y should be together, they should be concatenated. Now if I say f of x is equal to, say, x to the power of 3 negative 2x squared, this is solely a function of x. If I say f of y is equal to y times sine y, this is solely a function of y. Now if I say f of x times y, then the function has to be of this form. So for every x there should be a y with it. It doesn't matter what the degree or what the order that they carry, but they should be together, right? They are couples. That's the understanding that you should have, and they should be joined together. So having mentioned this, let us move on to solve this question. So foremost, we are given, what is given? We are given that x into y squared positive 2 times x squared y cubed times dx positive x squared y negative x to the power of 3 times y squared times dy is equal to 0. This is given. Now this is of the form m dx plus n dy is equal to 0. Fair enough. This is a differential equation, but it isn't yet an exact differential equation, right? So we got to do the test. So where m is equal to x into y squared positive 2x squared y cubed, and n is equal to x squared y negative x cubed y squared. Now we carry out dou m over dou y, differentiation of m partially with reference to y. This is going to give me 2 times xy and positive 6 times x squared y squared, and differentiating n with reference to x partially, this is going to be 2 times xy negative 3 times x squared y squared. Now let me box this so clearly you can see that if I were to name it as 2 and 3, clearly from 2 and 3 we see that dou m over dou y is not equal to dou n over dou x. This would mean that 1, I want to take this as 1 is not an exact differential equation. That is the meaning. So now our condition is to represent this in the form that we would be able to apply this integrating factor. So that would mean I need to make sure that there is a function involving xy. I can take a y out. There is a function involving xy, another function, and I can take a x out. Okay, so rewriting x into y squared positive 2x squared y cubed times dx positive x squared times y x to the power of 3 y squared times dy is equal to 0, we get, so what do we get? So now I'm going to take a y out, so xy positive 2 times x squared y squared, I'm taking a y out, so it's y dx positive, I'm going to take a x out, so it's going to be xy negative x squared times y squared times x dy is equal to 0. So this is exactly of the form f1 x and y together with y out times dx positive f2 x and y together with x out with dy is equal to 0, right? So this would mean my integrating factor would be 1 over mx negative ny. Okay, now consider mx negative ny. So what is my m? My m is this, my n is this, so let us use that. So that's going to be x into y squared positive 2 times x squared y cubed times x negative, my n is x squared y negative x cubed y squared times y, so that is nothing but x squared y squared positive 2 times x cubed y cubed negative x squared y squared negative negative positive x cubed and y squared. So is there anything we can cancel? X squared y squared gets cancelled. Now I got a 2x cubed y cubed and x, that is x cubed. Okay, this should be y cubed, right? X cubed y squared times y cubed negative negative positive. So these two can be added together, giving me 2 times, in fact 3 times x to the power of 3 y to the power of 3. So this is my mx negative ny. So therefore the integrating factor is equal to 1 over 3 times x cubed y cubed. So if I were to take this as sum 4, we will multiply 1 by 4, right? So that would give us, so this would mean 1 can now be rewritten as x y. So I can just use the original system. So x y squared positive 2 times x squared y cubed divided by 3 times x cubed y cubed times dx positive of x squared y negative x cubed y squared divided by 3 times x cubed y cubed times dy is equal to 0. This is what I've got. So this can be rewritten as x y squared divided by 3 x cubed y cubed positive 2 times x squared y cubed 3 over x cubed y cubed times dx positive x squared y divided by 3 times x cubed y cubed negative x cubed y squared divided by 3 times x cubed y cubed times dy is equal to 0. So now what we can do is we can cancel this, cancel this entirely, cancel this, and then cancel this, cancel this, cancel this, cancel this a bit, and cancel this, 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 cancel this. So that's what we have got now. So the question is, we have to rewrite this. This is going to be 1 over 3 times, I got a x squared there and a y there, positive 2 over 3 times, I got a x there, times dx, positive, I got a x there and a y squared there, and then 3 there and a y there and a dy there is equal to 0. So this is what we have got. So now we need to apply our check. So let's do that. So from here I get m is equal to 1 over 3x squared y, positive 2 over 3x, and my n is 1 over 3x y squared negative 1 over 3y. So this is what we've got. So now I would like to use this space that you see here to perform the check. So I would like to find out what is dou m over dou y. So differentiating this is going to give me negative 1 over 3 times y squared. This is going to be 0, right, because we want to find dou m over dou y, and dou n over dou x is equal to, this is going to give me, of course, one important thing, I need to get rid of this, I need to place this x squared, so that's also is important, so because it's x squared times y. So this is what we have got. So next comes, I need to differentiate n with reference to x partially. So that is going to give me negative 1 over 3 times x squared y squared. Right, so let me box this. So if I were to take this as 5 and 6, from 5 and 6 we see that dou m over dou y is equal to dou n over dou x, which means we have effectively reduced to the exact differentiable equation type. Okay, we have effectively reduced our 1. Okay, that's a parent equation. So now we need to follow the same process for exact differential equations as we have done in the earlier cases. So now we will obtain our integral m dx, which is nothing but integral of 1 over 3 times x squared y, positive 2 over 3 times x times dx. I can rewrite this as 1 over 3 times y, integral dx over x squared, positive 2 over 3 integral dx over x. This can be rewritten as 1 over 3y, x to the power of negative 2 times dx, positive 2 over 3 integral dx over x. This is 1 over 3y. This is x to the power of negative 2 positive 1 divided by negative 2 positive 1. And this is going to be 2 over 3 ln of x. I can simplify this as 1 over x minus 2 plus 1, that's going to give me a negative 1. So I can write that like that. So 2 over 3 times ln x. So this is negative 1 over 3 times xy, positive 2 over 3 times ln x. So this is my integral m dx. Now therefore dou over dou y of integral m dx, we need this, right, is equal to dou over dou y of negative 1 over 3 times xy, positive 2 over 3 times ln x. This one is differentiating this entire thing with reference to y partially. So if I were to do that, I would get 1 over y squared, right, with the negative sign. So that one will get neutralized with the negative sign. So this is what I will have for dou y of integral m dx. So hence we need to obtain integral n negative of dou over dou y of integral m dx times dy is equal to integral, my n is this, so I substitute 1 over 3 times x y squared negative 1 over 3 times y, followed by a negative sign, and then this quantity 1 over 3 times x y squared, and then multiply with dy. I can rewrite that as integral 1 over 3 times x y squared negative 1 over 3 y negative 1 over 3 times x y squared times dy, which is equal to, I can clearly cancel the positive with the negative, giving me 1 over 3 times integral dy over y, which is negative 1 over 3 ln y. Of course, I can take that to the index and then I can perform it, but for now I think I will just have it as it is, so it's okay. So this is what we have got, and I'm ready to settle for that. So hence the solution. Okay, so what's the solution? Solution is integral m dx positive integral n negative dou over dou y of integral m dx times dy is equal to c. This is the solution. So my integral m dx is negative 1 over 3 times xy, positive 2 over 3 times ln x, and this is nothing but this, negative 1 over 3 times ln y is equal to c. So probably I can rewrite this as 2 over 3 times ln x, negative 1 over 3 times ln y, negative 1 over 3 times xy is equal to c. I think I'll settle for this. If you want to simplify this further, you can simplify this. Students, we are now moving on to the third form. Now, when would we encounter a form of this nature? So I'm going to give you the statement. Now we are given that m dx plus n dy is equal to 0, and if we are able to represent which one? This expression, say let me call it as A. If you are able to represent A as 1 over n times dou m over dou y negative dou n over dou x to be equal to some function of x or some constant k, then the integrating factor that we would have to take should be e raised to the power of integral f of x dx if it is a function of x, or if it is a constant, then the integrating factor should be e raised to the power of integral k times dx. So this is a very important definition that we should follow. Now all these things happens because of the fact dou m over dou y is not equal to dou n over dou x. So I have that in mind. So now what I'm going to do is I'm going to solve this question. I'm going to show you how to implement the all-important form that we have in this particular lesson. So let's do that. So to start off with, I'm going to take this as 1, and then I'm going to say from 1 we know that. So what do we know from 1? We know that m is equal to 3 times xy negative 2 times ay squared, and my n is x squared negative 2 times ayx. So we find out dou m over dou y, differentiating m with reference to y partially. So that's going to give me 3 times x. This is going to give me 4 times ay. And this is dou n over dou x. Differentiation of this is going to be 2x. Differentiation of this is going to be 2ay. Now clearly, if you were to observe this, so I'm going to take this as 2 and 3. I can state that from 2 and 3 we observe that dou m over dou y is not equal to dou n over dou x. Also 1 can be represented as, so I'm trying to achieve this representation, okay? So that is very critical. So dou n, to start off with dou m over dou y. What is dou m over dou y? Okay, so let me write it. Consider 1 over n times dou m over dou y negative dou n over dou x, which is equal to 1 over my n. My n is this, so let me write that down. X squared negative 2 times ayx, right? So dou m over dou y. So dou m over dou y is this, 3x negative 4 times ay, followed by a negative sign, and dou n over dou x is this, 2x negative 2ay. So we are making a check. So if this is true, so this is going to be 3x negative 2x, and that would give me a x, and negative 4ay positive 2ay would give me negative 2ay. This has to be divided by x squared negative 2ay. N is 2ax. Okay, so if I were to take a x out, so this is going to be x negative 2ay divided by x of x negative 2ay. Now clearly this can be cancelled. The numerator was the denominator, giving me 1 over x, which is nothing but a function of x. So the requirement is satisfied, right? If this is equal to a function of x, then I can use the integrating factor to be as e raised to the power of integral fx times dx. Okay, so this means the integrating factor is going to be e raised to the power of integral f of x times dx. In this case, it is e raised to the power of 1 over x. So it's going to be dx over x, which is nothing but e raised to the power of ln x, and my e and ln can be cancelled, giving me x. So all these things is for your understanding. So we got the integrating factor. Now we can solve the question. Now let me take this as 4. Now what we have to do is we have to take 4 and multiply 1. So every element has to be multiplied by the integrating factor. That's exactly what we're going to do now. So now the problem can be rewritten as 3 times x, y. This is the original problem, right? 2 times followed by 2 times a y squared times the dx. I will have to multiply by the integrating factor, followed by positive x times x squared negative 2 times 2ayx times dy is equal to 0. So simplifying this is going to be 3 times x squared y negative 2 times ax y squared times dx, followed by x to the power of 3 negative 2 times a y x squared times dy is equal to 0. So all these things have occurred because we have multiplied the integrating factor. Now from here I get m is equal to 3 times x squared y negative 2ax y squared, and my n is x to the power of 3 negative 2 times a y x squared. So now I need to make the check. Okay, so find dou m over dou y. Differentiating this with reference to y partially, this is going to give me 3 times x squared. Differentiation of y is 1. So this is going to give me minus 4 times axy, and differentiating n with reference to x partially, this is going to give me 3 times x squared, and this is going to give me 4 times axy. So if I were to box this and probably name it as say 6 and 7, so I can state from 6 and 7 we observe that 1 has been converted or reduced to an exact differential equation, right? So therefore we will consider integral m dx. What is that? Which is equal to integral of 3 times x squared y negative 2 times ax y squared times dx, which is nothing but, I take 3 out, y out, is going to be x squared times dx. I take 2 out, I take a out, I take y squared out, and I got x into dx. So this is going to give me 3 times y, x to the power of 3 divided by 3, negative 2 times a times y squared, x to the power of 2 divided by 2. Of course, the 3 can be cancelled, the 2 can be cancelled, giving me x cubed y negative x squared y squared. Of course, there is a there. So this is my integral m dx. So therefore, dou over dou y of integral m dx is equal to dou over dou y of x to the power of 3y negative a times x squared times y squared. Differentiating this with reference to y would give me x cubed. This differentiation would give me 2 times x squared times and y. Of course, there's a there, so I substitute that a there. So now we need to obtain, I would say, consider integral of n negative dou over dou y of integral m dx times dy, right? So this is equal to integral, my n is this quantity which you see here, so I substitute that. There's going to be x to the power of 3 negative 2 times a y x squared, followed by a negative sign. This quantity is going to be x to the power of 3 negative 2 times a x squared y, has to be multiplied with dy. This can be rewritten as x to the power of 3 negative 2ay x squared negative x cubed positive 2ay x squared y times dy. Now clearly positive x cubed, negative 2a x y squared, positive 2a x y squared can be cancelled, giving me, I get a 0 there. So therefore the solution is integral m dx is equal to constant c. So my integral m dx is the value that you see here. So it's going to be x cubed y negative a times x squared times y squared is equal to c. So this is what we have got for our solution, and that's a good place for us to stop with the boxing of the solution. Students, we are heading to form 4. Now, this particular form is the exact opposite of the form which we have just studied. So what is the meaning of it? The meaning is, suppose we are given m dx plus n dy is equal to 0, and we can obtain an expression of the form 1 over m times dou n over dou x negative dou m over dou y to be equal to some function of y or a constant k, then the integrating factor is going to be e raised to the power of f of y times dy if it is f of y. On the contrary, the integrating factor would be e raised to the power of integral k times dy if it is k. So the entire idea lies on this act of obtaining the expression to be some function of f of y. So this is important. So this is actually 1 over m, and if we are able to achieve this, then the entire question can be reduced to an exact differential equation, and then subsequently it can be solved. So now we are given this question. The foremost what we have to do is we will have to make the check. So as usual, I'm going to take this as 1, and then I'm going to take m to be as equal to y raised to the power of 4 positive 2 times y. This is my m, and my n is x y cubed positive 2 times y raised to the power of 4 negative 4 times x. So from here I need to find dou m divided by dou y. This is going to give me 4 times y raised to the power of 3 positive 2, and dou n over dou x is going to give me y cubed, and this will become 0, this will become negative 4. So if I were to box this and take this as 2 and 3, so from 2 and 3 we observe that. So what is the observation we got? We observe that dou m over dou y is not equal to dou n over dou x. So that would mean we will have to have a mechanism by which we can convert the given differential equation into an exact differential equation, so the solution is possible. So now what we are going to do is we are going to check for this expression, or in other words check if this expression leads to a function of y. Okay, so that's exactly what we are going to do. So now consider 1 over m of dou n over dou x negative dou m over dou y, which is equal to, my m is this, so y raised to the power of 4 positive 2 times y times dou n over dou x, that's going to be y cubed negative 4 negative dou m over dou y, that's going to be negative 4y cubed followed by negative 2. So this is exactly what I've got. So from here, y cubed negative 4y cubed, that's going to be negative 3y cubed. So negative 4 negative 2 is going to give me negative 6 divided by the denominator, which is, I'm just writing it as a denominator. Okay. Now what we can do is, I will use this space over here. So this is equal to, I'm going to simplify this. I'm going to take negative 3 out, and that would give me y cubed positive 2 divided by, I'm going to take from the denominator a y out. If I take a y out, I would get y to the power of 3 positive 2. So clearly these two can be cancelled, giving me negative 3 over y, which is nothing but a function of y. So I now have a function of y, which is what is required, right? This is a function of y. So once this is a function of y, I can write the integrating factor. Therefore, integrating factor is e raised to the power of integral f of y, which is negative 3 over y times dy. This is going to give me e raised to the power of ln of y. Of course, there's a negative 3 there. I can push this negative 3 there to the index there. And then ln and e gets cancelled. So there's going to be y raised to the power of negative 3. I can subsequently rewrite this as 1 over y cubed. Right? This is my integrating factor. So I need to multiply this. I need to use this and multiply every term in equation 1. And then make the check for dou m over dou y and dou n over dou x. That's exactly what we are going to do. We have got this. As I mentioned to you, we have multiplied the equation with the integrating factor. Now I can rewrite this as y raised to the power of 4 divided by y cubed, positive 2 times y divided by y cubed times dy, positive xy cubed divided by y cubed, positive 2 times y raised to the power of 4 divided by y cubed, negative 4 times x divided by y cubed times dy is equal to 0. This is what we have got. This can be reduced. This is going to be y positive 2 over y squared times dy, and then this can be reduced. X, I can cancel this, and this can be reduced. So 2 times y, and in fact let me just cancel this and cancel this. So I got 2y, and we can't do anything about this, so it's going to be 4x over y cubed times dy is equal to 0. So clearly my m is y positive 2 over y squared, and my n is x positive 2y negative 4x divided by y cubed. This is what I've got. Now I need to find dou m over dou y. Differential of y is 1. This is going to be y squared, right? So if I were to rewrite this as, I'm just using the space, 2 times y raised to the power of negative 2. If I were to differentiate this, I would get negative 2 times y raised to the power of negative 3, which is going to be negative 2 times y cubed, with the quantity being present in the denominator. So that's exactly what's going to happen. So I got a 2 here, and probably I can rewrite this as negative 4 over y cubed, and my dou n over dou x, this is going to give me 1, this is going to give me 4 over y cubed. So that is working out really well. So clearly, if I were to take this as say 5 or 6, I can state from 5 and 6, we see that dou m over dou y is equal to dou n over dou x. So that means 1 has been reduced to an exact differential equation. So we have achieved that. So now what we will do is we will consider integral of m dx, which is nothing but integral y positive 2 over y squared times dx. I'm going to take y out as a constant, so this is going to be integral dx positive 2 over y squared integral dx, which is going to be xy over, this is followed by 2 times x over y squared. So this is going to be my integral m dx. So therefore dou over dou y of integral m dx is equal to dou over dou y of x into y positive 2x over y squared. This is differentiation with reference to y, that gives me x. This is differentiation with reference to y again. So as I mentioned to you, this is going to be y raised to the power of minus 2. So if I were to differentiate this, I would be getting negative 2 times y raised to the power of negative 3. This is what I would be getting. Okay, so I can rewrite that as x negative 4 times x divided by y cubed. So this is my dou over dou y of integral m dx value. So therefore, now consider integral n negative dou over dou y of integral m dx times dy, which is equal to integral my n is this, right? Substitute this value. So that's going to be x positive 2y negative 4 times x divided by y cubed, followed by a negative sign and the x negative 4x over y cubed times dy. So I can rewrite this as integral x positive 2y negative 4x over y cubed negative x positive 4x over y cubed times dy. So positive x, negative 4x over y cubed, positive 4x over y cubed can be cancelled, giving me 2 times integral y times dy, which is 2 times y squared over 2. So the 2 and b cancelled, giving me y squared. So this is for this, right? So hence the solution. So what's the solution? Hence the solution is integral m dx plus n negative dou over dou y of integral m dx times dy is equal to c becomes integral m dx. What is integral m dx? Integral m dx is the value that we have got. So that's going to be x y positive 2 times x over y squared positive. This whole value is found to be as y squared. So y squared is equal to constant c. Now you can either leave it like this or multiply everything by y squared. So I feel this is a good place to stop, unless or until you would want it to be simplified still further. Students, this is the final form of reducible equations to the exact differential equation. Now in this case, if we are given, say, m dx plus n dy is equal to 0, of course this is a differential equation, and for sure we know that dou m over dou y is not equal to dou n over dou x. We know this situation, and since this is a differential equation, if we are able to represent this differential equation in the following fashion, say x raised to the power of a times y raised to the power of b times, say, some p times y dx followed by some q times x dy positive x raised to the power of some c times y raised to the power of some d times r times some y dx positive s times some x dy is equal to 0. If we are able to achieve this, then of course I need to specify that a comma b comma c comma d comma p comma q comma r and s are constants. Then the integrating factor that we would be using should be of the form x raised to the power of h times y raised to the power of k. So this is the integrating factor. Of course you might be asking me, what is the value of h and what is the value of k? That is exactly what we are going to do. We are going to be finding the value of h and k. So the most important point that we will have to focus here is to convert the given differential equation into the equation that I have shown you. If you are able to achieve this, then the integrating factor that we have to use should be of the form x raised to the power of h times y raised to the power of k. So we will do a simple question to understand this. So this is the question I was talking to you about. So we will achieve the expression that we are looking for, and that is going to be x raised to the power of a times y raised to the power of b times p times y times dx positive q times x times dy positive x raised to the power of c y raised to the power of d times r times y times dx positive s times x times dy is equal to 0. As I mentioned to you, a comma b comma c comma d comma p comma q comma r, yes, they are all constants. So what I wish to do is, as usual, I'm going to take this as 1, and then I'm going to remove the parenthesis. I'm going to distribute it. So this is going to be y cubed times dx negative 2yx squared times dx positive 2x y squared times dy negative x cubed times dy. Now if you were to see here, for every dx there is a dy. So I will have to suitably club the terms so that for every dx I have a dy, and let's do that. So foremost, what I will do is I will just take these two together and I will club them. Of course, on the right hand side I got equal to 0, so I will write y cubed times dx positive 2 times x y squared times dy. This is one term, and then I will club the other term. So probably I will place a positive sign and take a whole parenthesis out, and then take a negative sign out, and then rewrite the dx term and a y term, right? So that's going to be 2 times x squared y dx term followed by a positive x cubed terms times dy. So this is equal to 0. So we are trying to get the representation that we are looking forward to. So now what I'm going to do is I'm going to take y squared out. So if I were to take a y squared out, then I would get this quantity. So it's going to be y squared out, and I get a y times dx positive 2 times x times dy, and then positive I take x squared term out. So if I take x squared term out, this is going to be 2 times y dx positive x times dy is equal to 0. So I can bring this out. I just want to keep the positive sign because I want you all to see the format, the exact pattern that I've got here. Now this is nothing but, I can rewrite this as some x to the power of 0 y squared times y dx positive 2 times x dy positive. Of course I can take this x squared out, and then I have a y raised to the power of 0, and this is going to be negative of 2 times y dx positive x times dy is equal to 0. Of course you got these zeros just to make you understand that the value of a is 0, and in this case the value of d is 0, but they are still constants, right? So if you were to compare it, we have actually achieved what we wanted, right? Now after we have done this, we will have to choose the integrating factor. Now in all cases the integrating factor for this is going to be this. The integrating factor is going to be x to the power of h y raised to the power of k in all cases for problems of this nature, because from here we will have to get the value of h and get the value of k. So that is exactly what we have to do. Now we are not going to be using this. This has been done just for you all to understand that I am able to bring the given problem into the expression that is required of, so that I am able to take the integrating factor in this fashion, right? So we will be only using this, the given question. So let me write that down. So multiply 1, say if I were to take this as say sum 3, multiply 1 with 3. I can do that. Now of course I'm able to do all those things because this is going to fail the exact differentiation check. So let me just for sake of consistency, I will just show you that. Okay, clearly we see that dou m over dou y is not equal to dou n over dou x. Okay, for the fact when m is equal to y cubed negative 2yx squared and n is equal to 2x y squared negative x cubed, dou m over dou y is equal to 3 times y squared negative 2 times x squared, and dou n over dou x is equal to 2 times y squared negative 3 times x squared. So clearly we are on the right track, right? Both of them are not the same. So let me just show you, they are failed. So actually we should have mentioned this and then we should have proceeded to checking it, but never mind. The very fact that we have a pattern here, we are checking for the pattern here, is because dou m over dou y is not equal to dou n over dou x, so it has already failed. But this is just for your understanding. Okay, so now what I'm going to do is I'm going to take 1 and multiply by the integrating factor. What is that? X raised to the power of h times y raised to the power of k. So therefore 1 can be rewritten as x raised to the power of h times y raised to the power of k times y cubed negative 2 times y x squared times dx positive x raised to the power of h y raised to the power of k 2 times x y squared negative x cubed times dy is equal to 0. So from here I can state m is equal to x raised to the power of h y raised to the power of k times y cubed negative 2 times y x squared, and n is x raised to the power of h y raised to the power of k times 2 times x y squared negative x cubed. Now I can bring this inside, remove the parenthesis, so x raised to the power of h, y raised to the power of k positive 3, and 2 times, this is going to be y raised to the power of k positive 1 and x raised to the power of h positive 2. This is, excuse me, this is my m, and my n, excuse me, my n is 2 times x raised to the power of h positive 1 y raised to the power of k positive 2 negative x raised to the power of h positive 3 y raised to the power of k. So this is what we have got for m and n. So now what we have to do is we will have to find dou m over dou y. So dou m over dou y, so this is equal to, differentiating this with reference to y partially, so x power k stands as it is, so this is going to be k positive 3 times y raised to the power of k, I reduce it by 1, so it's going to be k positive 2, so negative 2 times differentiation of this with reference to y is going to be 2 times of k positive 1 times y raised to the power of k positive 1 minus 1, that's going to be k, right, times x raised to the power of h positive 2. So now comes dou n over dou x, which is equal to 2 times of h positive 1 times x raised to the power of h times y raised to the power of k positive 2 negative h positive 3 times x raised to the power of h positive 2 times y raised to the power of k. Now we can simplify this and rewrite it just to be a little bit consistent. So in fact this is fine. Now clearly what we have to do is probably for m, just for sake of comparison, I'm going to rewrite this as k positive 3 times x raised to the power of k times y raised to the power of k positive 2 negative 2 times k positive 1 x raised to the power of h positive 2 times y raised to the power of k. And for dou n over dou x, I'm going to do the same thing. So 2 times of h positive 1 times x raised to the power of h times y raised to the power of k positive 2. One small correction, this is x raised to the power of h, okay, and everything else is fine. Alright, so followed by negative h positive 3 of x raised to the power of h positive 2 y raised to the power of k. Okay, that is fine. So now clearly comparing dou m over dou y and dou n over dou x, we find that dou m over dou y is equal to dou n over dou x. This is x raised to the power of h, y raised to the power of k positive 2. This is x raised to the power of h, y raised to the power of k positive 2. This is x raised to the power of h positive 2, y raised to the power of k, x raised to the power of h positive 2, y raised to the power of k. So we can compare and see that these two are equal. You can also view it in this fashion. Now these two ought to be equal. Now for them to be equal, the coefficients should be equal, right? You can make a judgment like that. So equating, the best word to use in this sense is equating, we get. So what do we get? If I were to equate these two, I get k positive 3 is equal to 2 times of h positive 1, and then negative 2 times of k positive 1 is equal to negative h positive 3. So from your negative 2k, negative 2 is negative h negative 3. So if I were to rewrite this as h negative 2k, I get negative 3 positive 2, which would mean I get h negative 2k is equal to negative 1. So this is one system, and over here I get 2h negative k, and over here I get a 3 and I get a minus 2. So this would mean I have a 2h negative k is equal to 1. This is another system. So I'm going to place these two systems together and evaluate for values of h and k. So if I were to take this as 6 and 7, I multiply 6 by 2. So that's going to be 4h negative 2k is equal to 2, and added with 7, that's going to be h negative 2k is equal to negative 1. I change the sign. I get negative, negative, positive, negative, positive. This is 3. This is 3h. So therefore h is equal to 1. H is equal to 1. Then if I were to substitute h is equal to 1 here, So this would imply 6 would give me negative k is equal to 1, negative 2. So this is going to be positive 2, it goes here negative 2. So this will give me negative 1. So negative k is equal to 1. So this means k is equal to 1. So I've got h is equal to 1, k is equal to 1. So therefore, let me write that down here. Therefore, the integrating factor which we started as x power h y power k is actually xy. So what we should do, we should multiply the given system by x and y. So if I were to take this as 1 prime, so let me just place start. If I were to take this as 1 prime, so we can now have a new equation. So let's do that. So hence we have so 1 prime is now rewritten as xy times y cubed negative 2 times y x squared times dx positive xy times 2 times xy squared negative x to the power of 3 times dy is equal to 0. Right? So you have to multiply this out, you get x y to the power of 4 negative 2 times x to the power of 3 y raised to the power of 2 times dx positive 2 times x squared y raised to the power of 3 negative x raised to the power of 4 times y times dy is equal to 0. So this is what you've got. Now clearly I take m is equal to x y raised to the power of 4 negative 2 times x cubed y squared, and my n is 2 times x squared y cubed negative x to the power of 4 times y. So I find dou m over dou y is 4 times x y cubed negative 4 times x cubed y, and dou n over dou x is 4 times x y cubed negative 4 times x cubed y. So this is working out really beautifully, you can clearly see that. So if you have to take it as say 6 or 7, probably 8 and 9. From 8 and 9 we see that dou m over dou y is equal to dou n over dou x. So this means we have successfully reduced 1 or 1 dash to exact differential equation, right? So once we have reduced it to the exact differential equation, we can go on to consider integral m dx, so which is nothing but integration of x into y raised to the power of 4 negative 2 times x cubed y squared times dx. Y is a constant, so you get integral x times dx negative 2 times y squared integral of x to the power of 3 dx. This is y power 4 x squared divided by 2 negative 2 times y squared x power 4 divided by 4. This can be rewritten as x squared y power 4 over 2 negative x to the power of 4 y squared. 2 divides 4 2 times. So this is what you have got for integral m dx. So therefore dou over dou y of integral m dx has to be found out. So differentiation of this x squared y to the power of 4 divided by 2 negative x to the power of 4 y squared divided by 2. This is equal to differentiation with reference to y partially. So 4 times y power 3 x squared divided by 2 negative 2 times y times x to the power of 4 divided by 2. 2 divides here 2 times, so this is 2 times x squared y power 3. 2 and 2 can be cancelled, followed by negative x power 4 y. This is my dou over dou y of integral m dx. Now consider integral n negative dou over dou y of integral m dx times dy, which is equal to integral, my n is this, you can use this value, so that's going to be 2 times x squared y cubed negative x to the power of 4y, followed by a negative sign and a 2 times x squared y power 3 negative x to the power of 4 times y times dy, right? So this can be rewritten as 2 times x squared y cubed negative x power 4y negative 2 times x squared y cubed positive x to the power of 4y times dy. Now 2 times x squared y cubed can be cancelled with negative 2 times x squared y cubed. X to the power of 4y with a negative sign can be cancelled with x to the power of 4y with a positive sign, giving me 0. So therefore what happens to the solution? So therefore the solution is going to be integral m dx is equal to c, because this is going to be 0, right? So what is integral m dx? Integral m dx is this quantity, so write that down. So x squared y power 4 divided by 2 negative x to the power of 4 y squared divided by 2 is equal to c. You can either reuse it or you can simply stop here depending on your requirement. I think this is the right place to stop, students. Thank you so much.